Hello everyone. Hi, good evening to all of you. We will start with our discussion. Today we will be discussing previous year's assignment 6 for analog circuits. Let's start. Okay. Week 6, assignment 6. First question is you have to tell, sorry. You have to tell if the statement is correct or not. All right. First statement is what is first statement is diode shows non-reciprocity and non-linearity. Second option is diode shows non-reciprocity and linearity. Third option is diode shows reciprocity and non-linearity. Fourth option is diode shows reciprocity and linearity. So these out of these four statements, you have to tell which one is the correct statement. So you think about it. You think about the different kinds of biases and how a diode acts like a switch, and from there you can find out the characteristic of a diode and if the diode is reciprocal and linear or not. Okay, so I'm giving you 2 minutes for this question. Okay, so what do you think? Which is the correct statement? Tell me. It can be wrong also. It doesn't matter if you are giving a wrong statement. What do you think? Which is a correct statement for this question? Go ahead. No, no one wants to say anything. Okay. So here, so here it is asked about a diode, right? It is the question is asked about a diode, isn't it? So we know that for a diode there is a forward bias. If the diode is forward biased, it acts like a switch, right? A diode is acts like a switch. When when it is forward biased, it is on, and when it is reverse biased, it is off. One second. Yeah. Sorry everyone. So where was I? Yeah. So it is when it is forward biased, it acts like on, and when it is reverse biased, it acts like switched off, right? So for linear system, it needs to have linearity. It should show linearity, whereas diode does not show linearity at all, right? You can see here, right? So it is non-linear. Another thing, okay, so about reciprocity. So what does hello, I'm audible, right? I'm audible to everyone.
Yes, audible.
Okay, okay, ठीक है. So yeah, so what does reciprocity mean? Reciprocity means that if we give certain a voltage at point 1, let's say this is point 1, this is point 2. So if we give uh, v voltage at point 1 and we are achieving I voltage at point 2, then reciprocity means that if we are giving, this is point 1 and this is point 2. One second, one second everyone. Yeah, so if at point 1, if we give current I, then if a system is reciprocal, then it should give voltage V at point 2, right? It should give voltage V at point 2, but we already know that,
Screen is not audible.
sorry, hello, hello, once,
Ah, yes, it is visible now.
huh, am I audible? Am I audible?
Yes, ma'am, you are audible.
Yes. So again, same
Yes,
thing.
you are.
Yes. So again, same thing that at point 1, if we are giving current I, then at point 2 it should give current voltage V. This reciprocity, but this is not shown in diode because we already know that it acts as short circuited only in forward bias. If it is reverse bias, it is open circuit, right? But which means that it's a switched off. So it does not show reciprocity property uh, uh, in the circuit. This diode does not show reciprocity, and it is thus non reciprocal in nature. So here, which one is the correct statement? First statement, right? Where it says that diode shows non-reciprocity and non-linearity, right? So this is the correct answer. Let's go and try to find out correct answer for the second one. Okay, so a Chebyshev prototype filter is supposed to be designed with a value of epsilon e is equals to 0.46. What will be the maximum? What will be the value of maximum attenuation? Okay, so this is the question. Here in the question it is asked, if here epsilon value is given to you. One second. Yes. So where was I? Yeah. So what was I? So here a Chebyshev prototype filter is given, right? And value of epsilon is 0.46. Now you have to find out the maximum attenuation, which is A max. So you know in the lectures given by Jayanta sir in the NPTEL analog circuits, you have given a formula for this type of question, and I hope that you have gone through the lectures, right? And I want you to solve this question and tell me the answer. How much time should I give you? Okay, take 2 minutes and try to solve this question. It's an easy question, right? Yeah. So try to solve this question. I'm giving you 2 minutes.
It is 1.99 dB.
1.99 dB. Okay. What about?
It is 1.99 dB.
Okay. All right. What about others? What others think? Okay. Solve it. I'm giving you 2 minutes for others. Okay. So did others try to solve this question? Okay. So how to solve this question? Can someone tell me? से सॉल्व कैसे करना है इस क्वेश्चन को? Oh, okay. All right. Let's discuss the solution then. So, so maximum attenuation is given by 10 log. This is in dB, right? This is in 1 second. 0.833 dB. Yeah. So, the formula for Chebyshev prototype filter, the maximum attenuation it can achieve is 10 log 1 plus e square, right? 10 log 1 plus epsilon square. This is epsilon 10 plus. So epsilon we already know. We'll put it here. right? And we got the value. We'll solve it and we got the value of A maximum. This is maximum attenuation possible. That is 0.833, and here it is asked what will be the value of maximum attenuation. So we'll round it off and we will get 1 dB. So answer C. So if both Chebyshev filter and Butterworth filter are of same filter order, the Chebyshev filter will have advantage over Butterworth filter. So first statement is if both Chebyshev filter and Butterworth filter are of same filter order, so it is saying that Chebyshev filter will be advantageous to use. First is this statement. Second statement is the attenuation between the pass band and stop band is much steeper than the Butterworth filter. Okay, so these are the two statements. Now you have to tell if the both the statements are correct or not, and if both are correct, if B is the correct reason for statement A or not. So go ahead, try to solve this question, and then we'll try to give understand this statement and give the correct option for this one, and then we'll discuss it.
And the option is A.
Okay.
First option is the correct answer.
Okay, what about others? What others think? Okay, try to understand. Okay, think about it. One more minute I will give you. Okay, so yes, statement first statement is correct. First option is the correct answer. That statement A and B both are correct, and B is the correct reason behind statement A. So what happens generally is that this is the kind of response here it's a gain in dB, and this is, let's say, frequency, right, in hertz, and this is gain in dB. So for Chebyshev filter, we have we have something like this. No, one second. Right, so this is in dB, it's 0, and this is log of 1 plus epsilon square. So anyways, yeah, so this is something, we don't need to, so this is something for Chebyshev, and for Butterworth it is something like this. Hmm, one second. For Butterworth the response is something like this. So here the response is, so in a filter what we want that we get a very steep response. We want, for ideal condition, uh, this is ideal brick wall response, right? So this is ideal brick wall. So ideally we want a brick wall response, but that is not possible practically. So Butterworth kind of gives like this, whereas Chebyshev's response is like this. So it is steeper than Butterworth. So that is why Chebyshev filter has an advantage over Butterworth filter. And yes, why it happens? Because it is much steeper than the Butterworth filter. So option A is the correct answer. Let's go ahead. Let's go ahead and try to solve question number 4 here. So figure 1 shows transformation of a low pass filter into high pass filter with R is equals to 200 kilo ohms. C is equals to 5 microfarads. Cutoff frequency for low pass omega C is 100 radian per second, and cutoff frequency for high pass filter is 200 radian per second. What will be the value of inductor? Okay, so here it is saying कि there is a transformation happening from low pass filter to high pass filter. All right, and the R given here. So we are converting a low pass filter to high pass filter. Okay, and values of R is given, which is 200 kilo ohms. Value of C is given, which is 5 microfarads. Okay, now cutoff frequency for low pass is 100 radian per second, and cutoff frequency for high pass filter is 200 radian per second. So what will be the value of inductor? So cutoff frequency is given to us. We have to find out the value of inductor here. This we have to find out, right? So first you have to, what you have to do is, you have to put the value of this cutoff frequency, put the value of cutoff frequency, put the value of R in that formula. There, from there you can find C. With the help of C, yeah, so you can find out C. And for L, yeah, one second, cutoff frequency. And here also it's, you have the formula given to you. Put the value of R, you can get the value of L, right? So try to solve this question and then we'll discuss it. Okay, all options are visible to you, right? All the options are visible to you, right? Okay.
Yes, ma'am, visible.
Ha, okay, okay.
It is 10 Henry.
Okay. What about others? No one else is solving or what? Okay, how did you solve?
We have the formula 1 by omega c,
Hmm.
omega c dash into c.
Hmm. Okay. So you put there the all the values. Acha, ha. So you already have the value of C as well. Okay, so you don't need to even yeah. So value of C is given, R is given, value of omega C is given to you, and directly you will put it and you will get the value, right? Directly in the formula. So formula itself, yeah. So we know that omega C is the low pass filter cutoff frequency and omega dash is for high pass filters cutoff. So if you have gone through Jayanta sir's lectures, he has given this exact formula there, right? So you have to put this in, you have to put all the values in that formula, and the formula is that to find out the value of inductor, it is 1 upon the cutoff frequency, low pass filters cutoff frequency, high pass cutoff frequency, and the value of C. So we'll put it here and we'll get 10 henries. Yes, so 10 henry is the correct answer. Clear? 10 henry is the correct answer. Okay, so let's go ahead and try to find out answer for question number 5. So question number 5 here.
Ma'am, but I have a question.
Hmm.
How to remember this formula?
Solve it actually. So it's not a big deal. You can solve these questions by yourself. But for that's the point, you know. So for if you go for exams like PSC for or for gate, so there you need to remember these kind of formulas. So it's better to always keep in practice for these formulas. And it's not like every lecture has only 2 3 formulas, I guess, right? So it's always better to keep in practice with this. Other than that, you have to solve the whole, you have to solve whole circuit, and then like you have to like low pass filter is something like this, and then high pass filter is like this, sorry, it will be like this. This is omega c dash. This is omega. So you have to solve it. You have to solve whole circuit. Then it will take more time for you to solve.
In the
Hmm.
in lectures, it is given that in the lectures it is given that
Hmm.
for a low pass filter to get a high pass,
Hmm.
j omega is replaced with omega c into omega c dash by j omega. But how we are using that, I don't know why we are using this
Why we are using what? Why we are using what?
to get a high.
Yeah. So you are
For
connecting.
here in the module it is given the from a low pass circuit to high pass, it is said that replace j omega with omega c into omega c dash by j omega.
J omega. What?
Why it is said that, like,
Omega.
what is the reason behind this?
So what is it said? Replace omega c dash by.
No, no, no.
Huh.
Replace j omega with omega c into omega c dash by j omega.
Yeah. Are because capac. Baba, it's a capacitor and inductor, na. So if you go through phase diagram, it has a 90-degree difference, na. C and L are not on the same phase, right? Like resistors
Okay.
have same phase, whereas different phases. So it's always
Okay.
negative J. Are you getting?
Okay.
Ha.
I'm comfortable with negative j. Ah, 1 by j omega is okay. But why omega c into omega c dash in the numerator?
Okay, so tell me the formula. What formula is being discussed?
J omega is replaced with
J omega. ठीक है. J omega of this lower cutoff. J omega C is replaced with
yes, is replaced with omega c into
omega C. Omega C into, okay,
omega c dash
omega C dash
by j omega.
J omega naught, the center frequency. J omega, what is this omega?
No, it is just j omega.
So what is this omega here?
Here it is not j omega c. In the left side it is not j omega c. It is just j omega.
This J omega. So this is J omega.
Ah,
Yeah, this is center frequency. J omega naught and J omega naught. So basically, okay. So see, this is a low pass filter, right? This is omega C, and this is high pass filter, which is omega C dash. So there is a pass band filter, something like, no, one second.
when we are not talking about the passband
One
here,
second.
right?
Yes, yes. But I'm telling you something else. So, so here
Okay.
omega C and here omega C dash. Okay, and this is a center frequency which is omega naught. So this is what it is here. Omega naught. So basically, omega naught is not a center frequency like this, but it is basically omega C and omega C dash. Under root of omega C and one second.
Yes, it is just simply geometric mean of omega c and
Yes,
omega c dash.
GM. Yes, exactly. It is GM of omega C and omega C dash. Yeah. So this from here, this is the geometric mean, and this is how you can write it again. So this is what it is basically.
Okay.
Okay.
Okay, but okay, but ma'am, one more
Hmm.
thing. Okay, from that we got this.
Yeah. Yes. In other further questions also we'll solve, like, see, even in the next question itself we have something like this question, so we'll discuss it in the next question itself, the kind of thing that we are discussing right now. Okay. So here,
Okay,
you converted a
okay,
low
ma'am.
pass from a low pass to high pass, right? And we use low pass, like low pass cutoff frequency and high pass cutoff frequency, right? And did I explain the solution to all of you?
Okay.
Did I explain the solution of question 4 to others?
Yes,
Okay, okay.
yes, ma'am. Explain.
ठीक है, ठीक है. So let's go ahead. Yeah, so see, in this question, same kind of thing you have to do, but instead of a transformation from a low pass to high pass, here here we are transforming a low pass filter to a band pass filter. So exactly, so this what we are discussing now. Here it comes the same thing. So a low pass filter is transformed into a band pass filter. First is, what will be the quality factor of the band pass filter if cutoff frequency for low pass filter is 60 radian per second and cutoff frequency for band pass filter are omega 1 is equals to 20 radian per second and omega t 2 is equals to 8000 radian per second. Here it is saying a low pass filter is transformed into a band pass filter. Okay. So, and it is saying that the first thing that you have to find out is quality factor. Okay. So you have to find out is quality factor, and then you have to find it is saying that cutoff frequency for low pass filter, that is this. So here omega c is 60 radian and cutoff frequency for band pass filters are omega 1 and omega 2 is 20 and 8000. 8000. 800, sorry, 8000 radian per second. So first you have to find out quality factor. Okay.
It is option A 0.050.
Okay. What about others? Okay, so how you are saying option A? Go ahead. Yeah, option A is the correct answer. Go ahead.
Based on the formula,
Huh. What is the formula?
we have Q equal to omega naught by delta omega.
Hmm. Yes, correct. So, what does quality factor means?
Where
Yeah. So you put it in the formula. The value of omega naught, which is the GM of omega 1 and omega 2, and delta omega is the difference between omega 1 and omega 2, right?
yes, ma'am.
Hmm. Okay. But what does quality factor means? Can anyone tell me? Go ahead. Tell me what does like it's a filter, right?
How select
Hmm. Hmm.
how selective our circuit is,
Hmm. Yes. Very good.
how selective our filter is.
Huh? Okay. Uh, can you explain like what does that mean?
That means it must have narrow bandwidth.
Yes. Narrow pass band. Yeah. Very good. Yes.
Yes.
Quality factor of any kind of circuit means that how much it is in its like uh output it has to give, it is giving better, right? Suppose that there is a filter which have a bigger pass band, right? And there is a filter which has a very narrow pass band. So what will be good for a filter, right? That's a question. So don't you think like if we are sending a signal, if we have a very big pass band, then to extract the data out from that output, we have to then also apply different kinds of denoising filters, different kind of extra complex circuits on it to get to extract that data. Let's say this is the data here, so this is the data we want, but here we have to also, and this is the signal that we have, right? So this is the signal that we have, and when we put a pass band here, some this is what we are getting. But if we have a narrow, then only this kind of output we are finding with a narrow pass band. So that's what is a quality factor means, that if a band is narrow, we don't have to apply different complex circuits on it to extract the exact data out of it, right? If we have a bigger pass band on a for a filter, then we have to apply different circuits above and over the filter itself, whereas for narrow passband we don't have to do that. And that's where quality factor comes in. So if a good quality factor passband filter is used, then it means that our data has no more we don't have to extract our data from a pool of data, right? Okay, so this is what quality factor means. Understood?
You said we will discuss something
Huh.
more in the fourth question, right? In the next question.
Mm-hmm.
Could you please elaborate that point?
Yeah, so this is what, so the formula was given by sir now. So this is what basically it meant. That this omega naught, or this sir has said j omega, and here he has put j omega. It was the gm basically what sir was talking about. Okay.
Okay, then. Ma'am, other question I have is to transform a low pass to band pass, there the formula is different. Could you please erase these once? I'll say that formula once. Yes, the formula is J into omega by omega c is
J into omega by omega c.
by omega c
Hmm.
is replaced with q into j omega by omega naught plus omega naught by j omega.
Not by j omega.
Q is multiplied for both these terms.
Okay. This is center
How
frequency.
this formula?
This is lower cutoff. Okay, this is given by sir. Sir has given this.
Given by sir.
Yeah.
Yes, ma'am. Yes.
Okay. I need to check it out, and then we can discuss it in the next lecture. This question, and remind me of the maximum attenuation question. So we'll discuss it again. So I need to check it out, and need to check the
Okay,
formula and
ma'am.
everything.
Ma'am, is these lectures available? Recordings are available?
Yes, yes, recordings will be available. Hmm.
Is the recording?
Yes,
Where, ma'am? Where it will be available?
it will be available on YouTube.
And which channel?
Uh, okay, I need to send you the link. 1 second. So here, here is the link. Here, from here you can check it out, right? So okay, I will send you my email ID as well. gmail.com. Okay, so here you can give, also mail me if you have doubt. But if you want to, if you have any doubt, there is a section in SWAYAM portal itself. I will show you how to go there. So there you can also ask questions. Okay. Can you see my yeah, one second. So in the chat box I have given you the link of my YouTube channel. From there you can check it out, and even you can mail me on my email ID. But so those are one thing. Another way to go is like this. So you log in into your SWAYAM portal account, go to your courses, go to course. Hmm. So here there is a this kind of option is given to you, ask a question. Okay, so you can go here directly and ask the question. Okay, got it? So you here you can ask the question. So several students have already asked different questions. Here you can put your question as well. Okay. Okay.
Yes, ma'am.
Okay. Huh. So where we were, let's go. Huh. So okay. So I will try to solve. I will discuss. Either I can do one thing. I will record it and put it on YouTube channel, and from there you can directly watch it. Will that be fine with you? The doubts you give me here on the chat.
Okay.
Huh. And then I will make a video of it, and I will post it and you can check it out. Okay.